Okay, so here's part 2. I'm going to start over with the slide. So what we're going to do is in the past part, on the first part of the video, I told you that I gave you the slope and the y-intercept, and you had to tell me which one was which. Now I'm going to give you the slope and the y-intercept, and you're going to plug it in. Okay, so we know that slope is going to be our m, and our y-intercept is our b. So you take the equation and you plug 3 over 5 in where the m goes. So we're going to plug 3 over 5 in here, and you're going to plug -2 in here, and it will look like this. So I replace the m with 3 over 5. I replace the b with -2. So now all you got to do from this point is just kind of clean it up. Get rid of double negatives, things like that. So we know that when we plus a negative, it just becomes minus. So here is your equation of a line. So if I give you the slope and the y-intercept, then you can give me an equation. If I give you an equation, you can give me the slope and the y-intercept. All right, so now we're going to write an equation given a slope. So given a slope and a point. Okay. So now you're going to take that equation that's very similar to y equals mx plus b, and it is y minus y1 equals m times x minus x1, where m is your slope, so m is still our slope, and the x1, y1 is going to be the point that's on the line. So that's going to be where that point goes. Here's your y, and here's your x for y equals mx plus b. So we're going to convert this into slope-intercept. All right, so find the equation of a line with a slope of -2. So that means, let me change colors here. So a slope of -2 and passes through this point. So this is the point that they are giving us. So this is your x1 and your y1. They want me to write it in slope-intercept form and in standard form. So not only are you going to have to plug it into this form, you're going to have to convert it to this form. Okay, so to start with, you take your, and I'll write it above, so y minus y1 equals m times x minus x1. So here's your m, so replace the m with 2, and your x1, y1. So your y1 is -12, so y minus -12, and then x minus -11. So all we've done here is plugged it in. We've done no math. You've just replaced the numbers. I'm sorry, replaced your variables with the numbers they are assigned. So now clean up your parentheses and your double negatives, things like that. So actually, let me do this, because this, all right. So now we've replaced all of that, so that kind of got out of order. So let me, let me do this. I'm going to delete this because I can do this faster if I just write it myself. Okay. So let me move all these little boxes out of the way. All right. So now, so going back here, so now I'm going to clean it all up. We know that 2 negatives make a positive, so this becomes y plus 12 equals -2 times x plus 11. So now this looks a little easier on the eye than all of this. So now I'm going to clean it up by distributing. So y plus 12 equals -2x minus 22. And now I'm going to subtract 12 from both sides so that I can get slope-intercept form. Y equals -2x minus 34. Yes, okay. So here is your slope-intercept form. Now they want me to convert it to standard form. So now I'm going to take my slope-intercept form. So let's do it in a different color. So y equals -2x minus 34. Now I'm going to make it where the x and the y is on the same side. So now I'm going to add 2x over here. So now I have 2x plus y equals negative 34. Now this is in standard form. And this one is in slope-intercept form. So they're interchangeable. So I can convert one into the other just by moving usually one or two things around, and then you're good to go. So now how do you write an equation if I give you 2 points? So now you're going to have this x and y, and then you're going to have this x and y. This will be your x1, y1, and this will be your x2, y2, because you have 2 points. So we already know that when you have 2 points, you can find slope. So with 2 points, I can find slope. So the first thing we're going to do is we're going to find the equation that goes through this point, and we're going to write it in slope-intercept form. So now, and from there, we're going to write it in standard form. So we're going to go and first find the slope. So slope is y2 minus y1, x2 minus x1. So plug your values in, x1, y1, x2, y2. I always assign them so I can just quickly look up and know which one I'm looking at. So this is y2 minus y1. y2 minus y1. This is x2 minus x1. x2 minus x1. So negative 1 minus 0 is negative 1. And 6 minus negative 4 means 6 plus 4. So there's our slope. So now that I have a slope, I'm going to choose this as my x1, y1, because that's what I assigned it, and here's my slope. So if I use the slope, negative 1 over 10, and you can choose either point, it does not matter because they're on the same line. So now I'm going to do negative 4, 0. So this will be my x1, y1. And now I'm going to do y minus y1 equals m x minus x1. So step 1, find your slope. Step 2, use point slope. So slope to point slope. So y minus y1 m times x minus x1. So first off, y minus 0, well, that's just y. These double negatives are going to become positive. So now distribute that. So that's negative 1 over 10 x minus 1 times 4 over 10. So this would be this is your slope-intercept form, okay? And you would want to reduce this right here. Always make sure you reduce. So let's say y is negative 1 over 10x minus 2 over 5. So this would be your final answer for your slope-intercept form. So this would be y equals mx plus b. But remember, they wanted us to do standard. So I'm going to work with this because it has the same denominator. So first off, what I'm going to do is I'm going to rewrite. So here's step 3 to turn it into standard form. So we've got y equals negative 1 over 10x minus 4 over 10. First thing I'm going to do is this has to be in the form ax plus by equals c. You don't want to leave it as fractions. It has to be whole numbers. So the first thing I'm going to do is multiply everything. I'm just going to multiply the entire equation by 10 because that way the denominator will go away. So 10 times y is 10y equals 10 times 1 is 10, 10 divided by 10, so negative 1. 10 times 4 is 40, 40 divided by 10, it's 4. So minus 4. So now all I have to do is add this 1x to both sides. So now you've got x plus 10y, because that cancels out, equals negative 4. And now we have standard form. Ax plus by equals c. So this would be your final answer. So find your slope. plug it into Pointslope, and then put it in standard form. All right. Now we're going to find equations of vertical and horizontal lines. This is going to go back to what I've been talking to y'all about, the whole Vux-Hoy. Okay, remember, if it is a vertical line, the slope is undefined. Undefined. And the equation is always x equals a constant. If you have a horizontal line, your slope is 0, and it's always y equals some constant. So find the equation of a line that's vertical to this one. So just to give you a visual, so if you have an equation, or you have your x and y axis, go ahead and graph that line. So that's -7, -2. So here is -7, -2. So I want to find the equation of the vertical line through this point. So if I have a vertical line through that point, so there's the vertical line, and I know my lines are super not straight, but so we know since it's vertical, according to Vux-Hoy, a vertical line has an equation that's x equals. So this is x equals. Well, what is x? -7. So your answer is -7. X equals -7. As long as it is a vertical line, your equation will say x equals, and it will equal the x value of your point. So for example, if they wanted the horizontal line that went through here, so if I did a horizontal line through here, and now I'm going to change the color of this horizontal line. I don't know if yellow is a good choice. Probably not. So if I did a horizontal line, and this thing is super wonky today. So if I did a horizontal line through that point, so horizontal lines always have y equals. So we know this equation is y equals. Well, what does y equal? What is the y value to your point? -2. So vertical equation, horizontal equation. Find a line, or sorry, find an equation of a line that's parallel. So remember, parallel means they don't touch. And it has to be parallel to this line right here, but it has to go through this point. So again, think about what it looks like. So first we have this equation right here, y equals -3. So let me get this right here, x and y. So go to the y-axis and find -3. 1, 2, 3. So we have an equation that is going to go through this because it says y equals. So since it says y equals, Hoy means it's going to be a horizontal line. So this is y equals -3. Now they want it to go through 10, 4. So go back to your origin, go over 10, and go up 4. So this point would be 10, 4. Now, if it's parallel, it has to be horizontal because that one's horizontal. If it was vertical, then they would both be vertical. So we have that equation. Now we have two parallel lines, or a set of parallel lines. And if this equation is y equals -3, then this one has to also be y equals. But what does y equal? It equals the y value of the point, y equals 4. So find the equation of a line, y equals 4. So basically, if you need the visualization, then graph the line they give you, graph the point they give you, and then draw your parallel lines. If you don't need the visual, then as long as you know that this is a horizontal line, then you know this one is also going to be horizontal. If they had said to graph an equation that, or to find an equation that is perpendicular, so let me talk about perpendicular for a second. If they wanted a perpendicular line, so a perpendicular line So if I have y equals -3, and then they want me to give 10 through 10, 4. So I want a perpendicular line. Okay, I am going to apologize for that and hope that you really didn't hear what he was hollering. We're housebreaking a dog, so yeah, it's a catastrophe around here. I hope you guys are having a much better day. Anyway, if I want a perpendicular line through this point, so if one of my equations is y equals, the other equation will be x equals. Okay, y equals and x equals, perpendicular lines. So if I want it to go through this point, then it's going to have to go through the x value of that point. So parallel will go through the y value if it's y equals, and perpendicular will go through the x. So going up here to this same point and graphing the line. So now I know that it's perpendicular. And the perpendicular means it's going to make a right angle. So we're going through this point, 10, 4. So y equals 4 is parallel, x equals 10 is perpendicular. So that should cover anything that my math lab will ask you about parallel and perpendicular, horizontal and vertical lines. All right, so now we're going to use point slope to solve problems. So now we're going to have a word problem, okay? This is the last part. So in 1997, Window World Incorporated had 50 employees. In 2012, the company had 85 employees. So in 1997, there were 50 employees. In 2012, there were 85 employees. So it says let X represent the number of years after 1997. Let Y represent the number of employees. So if you were to create a table, so 50 employees and 85 employees, we know we got that, right? So if X is representing the number of years after 1997, well, if in 1997 we had 50, then there's 0 years because that's where we're starting. And now how many years is 2012 from 1997? So that's like 15 years. So 15 years later, they got 35 more employees, okay? So we're going to assume the relationship between the years and the number of employees is linear, meaning y equals mx plus b. So when you see linear, that's what they're referring to. And we're going to write an equation describing the relationship. So the y-intercept is where you begin. Remember at the very first part of part 1 where I said b is the number that's by itself and it's where you begin on your graph. So if we had an xy axis here, and I'm only going to draw the first quadrant because everything's positive. So basically, when we begin in year 0, we have 50 employees. So my y-intercept would be 50. So that means b is 50. So now what we have to do is find the slope so we know how it looks. So slope, so you got your x1, y1, x2, y2. So slope is 85 minus 50 over 15 minus 0. So that's 35 over 15. So 35 over 15, and you want to make sure you reduce. Always, always, always reduce. So 35 divided by 15 reduces to 7 over 3. So our slope is 7 over 3. So m equals 7 over 3. I'm sorry, that's a little bit messy. So now if I'm going to write the equation, then I'm just going to say y equals, oh, that's not what I wanted to do. That's a really chunky line. All right, y equals m x plus d. So there is your part A. That is the equation of how many employees we have for every year. So we're going to rise 7 and run 3. So remember, x represents the number of years after 0. So year after 0, and y is employees. So if you rise 7, so every 7 years, you get 3 employees. So rise years, run employees. Now the next part says to use the equation to predict the number of employees that they have in 2007. So we know in the beginning we had 50. 15 years later, we had 85. So how many did we have in between that? Okay, so how many years is 2007 after 1997? So that means that X would be 10 in this case. So now we're going to figure out, well, if I'm 10 years later, how many employees is that? Okay, so we're going to plug that into the formula. So this is our part A. So we got our formula. So now let's plug it in and find out that the number of employees is 7 over 3 times 10 plus 50. So obviously we're just going to type that into our calculator. So 7 over 3 times 10 plus 50 is 73.3. Well, obviously we can't have 0.3 employee. So it's just going to be 73, okay? Because you can't have a partial employee. So when we began, we had 50 employees. 10 years later, we had 73. And then 5 years after that, we had 85. All right, so here it is. I'll just kind of move these so you can look at them. We found the slope first, just in case you can't read my writing. I'll scroll this up so we can see it a little better. And then you take they took this equation and plugged it in, but I did mine a little bit differently because I used, I think I totally did that wrong. No, I did not. So X is, yeah. So I looked at my table and realized that when X is 0, the Y value is your Y-intercept, okay? This point right here. So that's how I did that. I just looked at it just like we did in the very first part where I said, hey, if I give you the Y-intercept, then that's where you're going to begin. They're doing it such as this, so maybe they didn't give us the Y-intercept, then you would have done it this way. So you would have said, okay, I had 50 employees, X is 0. So you go through, plug it in, 7 over 3, X is 0, Y is 50. Just plugging it in from the table. And then add the 50 to both sides. I'm sorry, my grandson is in there making all kinds of noise. Get those out of the way. So there's the equation that we come up with on the front. Now we're going to use the equation and we're going to plug it all in. Oh my goodness. So 73 employees in 2007. I squeezed it all in on one slide because it doesn't really take that much to do these, so please don't get overwhelmed with them. So first thing, find your slope. Second thing, find your equation. Oops. Find your equation. And then third thing, plug it in to find your part B. So that is all of that in a nutshell. And I will see you guys at 7 p.m. on Tuesday, April 7th. Have a good one.